Thank you, Sean, for that introduction. As Sean mentioned, we are a partner with ChipEstimate. And I would like to talk today about our high-speed IP core offering for cloud infrastructure. So if you look at the next generation cloud or the data center, and how does it look like? So in that architecture, there are many servers, and server pretty much means there are a lot of processors, there are memory, there is storage. So I will cover, and there is networking. So it has the complete network of servers. And what I would like to show here is what are the different components from an IP perspective in that environment. Anyway, what I want to show here was all the different interconnects that is in the environment here. The first one I want to talk about is Rapidio. So when the processors are connected today, the best interconnect that's available today is Rapidio, serial Rapidio. And the third generation of interconnect, which is working at 10 gig performance, and that's already available now. And this is going to be the best way to connect the least latency and very low power, very low footprint. And it has one of the big benefit of Rapidio is a native hardware. So for example, if you take an Ethernet type of approach, you need to invest a huge amount of software, and your company may not have the wherewithal, you don't have the background to do an Ethernet type of connectivity, and also Ethernet is a very long latency. So for that reason, we recommend Rapidio for connecting for multiple processors together. And here we are talking about the ARM-based processors here. But if you look at the Intel architecture, they have something called QPI interface. So in the ARM-based architecture with the next generation data centers, the best connectivity for the processor is going to be the Rapidio connectivity. And the next one is the processor to IO communication. And in that case, the available technology, one of the best technology available is the PCI Express. And it does that job pretty well. And that can connect to Ethernet for networking. And finally, coming to storage. For storage in a server environment, it has always been a disk-based storage. And now the trend is changing. It's becoming more of a solid state storage. And the solid state is based on something called an NVM Express standard. And this is a brand new standard, and it has become very popular. And you will see many applications in storage around NVM Express in 2014 and 2015. So in this whole infrastructure, you can see many different components as an IP provider that we can provide. And one more thing, don't forget the memory technologies, which is the DDR4 and DDR3 technologies. And this is the latest and greatest of interface that's available outside. Now, what do we provide? We are a provider of high-speed serial interconnect. Previously, this team worked at GDA, so some of you may be aware of us with a different name. Now the team has come together again, and what we provide is all the different technologies that is going into the data center, and we are part of many consortiums, many organizations in the industry that is creating these technologies. The first one is the Rapidio. This is the Rapidio Trade Association out there. We are a member of that. The PCI Express, PCI SIG, we are a member of that. The NVM Express, and this is for the storage base technology. And finally, the hybrid memory queue, HMC. And we are a member of that. And we have created IP cores for each one of these technologies. And we have already created these IPs, we are licensed to customers. Not only the cores, we also have bridges and switches. For example, we have a PCI Express switch IP, which is used as a core outside. You can go and get a PCI Express chip from outside, but as a core, we can provide this IP that can be integrated in an SoC environment. And finally, the memory controllers. So we provide the DDR4, DDR3 memory controllers as well. So we are working in these high-speed technologies, and we are a provider of this course. So now when you look at what are the changes happening in the different interfaces, and the primary application of this interface is storage and communication networking. Basically, the technology, everyone is looking for increased speed. Every generation, it is going from 2 gig to 5 gig, 10 gig, and it's getting to about 15 gig. If you look at PCI Express, the third generation of PCI Express is 8 gig. They're looking at 15 gig for generation 4. Serial Rapid I/O, the third generation is already available, is 10 gig. And we will be looking at comparable speed for next generation. Similarly, memory technologies are increasing speed. Ethernet is increasing speed. It's going from 1 gig, 10 gig, 100 gig, 400 gig, and so on. The second part is the space. Everyone has limited space, and we want small footprint. And that means smaller number of prints, smaller number of IOs, smaller form factor. And that allows a better integration overall. Now the requirement is less power, less number of wires, so that less signal integrity issues. And of course, everyone is looking for a lower cost. And so we have to cater, when we create the high-speed interconnects, we need to make sure that we are making it faster, making it cheaper, making it a lower space and lower power. Now I will talk about a couple of our offering. The first one is the PCI Express. Now PCI Express is one technology, but you look at the flavors available in PCI Express. It could be many different combinations. So if you start from on the left, for example, the PCI Express could be on a different technology nodes. It could be on 28 nanometer, it could be on 65 nanometer. There is generation 1, 2, and 3, and getting to generation 4. There are 4 different generations. It could be on an FPGA, structured ASIC, or an ASIC application. Now coming to PCI Express itself, there are many flavors. There is endpoint, there is root complex, there is switch, there is hybrid, and so on. And if you combine with different bridges like AXI bridge or AHB bridge, that again adds more and more complexity to this system. The data path width, it could be a 32-bit data path, or it could be a 256-bit. It all depends on, if you want to work at a very good performance in an FPGA, for example, you may want it a 256-bit technology. The number of ports, it could be a by 1 to up to by 32 based on your application. So for example, if you have a very high speed video type of application, you probably need to have a much higher performance. So compute application. Whereas if you have a application which requires very low bandwidth, then it's a by 1 will do. The next technology we have developed, we have licensed is UNEX, which is the universal NVM Express controller, universal NVM Express controller. And the components of NVM Express, as I mentioned, is on the one side it is PCI Express. On the other side, it is going to be a flash sitting. So this is going to be put in a data center application, and we have created a bridge between the PCI subsystem to the flash subsystem. And this is a new standard. It's getting popular. Hope that 2014 and 15 become enormously, maybe even more people adopt this going forward. So we create the complete system. We have a development board. We can demonstrate the whole system from PCI Express to the flash, the whole area. The other one is our product is Rapid I/O. We call GRIO, and the GRIO Rapid controller. It's a right now 2.2 version, which is the 6.25, and it is getting to the 10 gig version. So we are enhancing this technology to the 10 gig. And as I showed you the first picture, it is the best technology available today for interconnecting CPUs, interconnecting multiple servers. It is the lowest latency application. This particular product is technology independent, silicon proven, system validated. Many customers worldwide use this particular technology, and if you look at today, in the LTE base station market, 100% of LTE base stations today work with serial Rapid I/O interconnect. And this is not very well known, but we are trying to promote it even more. But there are many more applications for serial rapid I/O. And it was in the base station market. It is getting into many industrial applications. There is a new initiative for space application. There is a new consortium that is happening for space applications. I see that many requirements for this technology from Asia in particular. And we are also, as I mentioned, we are also looking at connecting multiple servers with rapid I/O. So we have this particular IP. We also have the bridge towards AXI. We are bridge towards AHB as well. So we have all the components that are required to use this. And like I mentioned, is the next generation is the 10 gig speed. Okay, from an IP standpoint, what are the things that customers are looking for? So they are looking for better integration, better quality, and more verification. And reuse is very important as well. So these are the top 3 or 4 requirements from an IP perspective, IP user perspective. And we are taking care of this by multiple ways. One is by providing what the customer needs. The customer has a different application, different requirement, and we customize our IP on the fly in software by looking at the application and providing the right functionality, the right time to market, the right cost and performance. So we have the capability so that we can we have one core that can be utilized, and we can customize it in a way, the very automatic customization process that we can create the right IP. Finally, all our IPs are verified and validated in a system level environment. We work with Cadence as a verification IP partner. We work with Metagraphics, and we also work with Avery. So we work with all the different verification IP partners so that we create an IP that will work in various environments. So when the customer acquire our IP, as I mentioned, integration is #1 challenge for Silicon IP. And by providing something that is already working, it's already proven in a software environment as well as in a validation environment, we can make sure that we take care of the integration issue. The second one is the quality issue. Again, by making sure that we work with these different partners, we make sure that we have a better quality and combining and doing better verification. Okay, so what are the advantages? I will just go over one more time. The first one is we have these IPs. This team has been working with these IPs for almost 10 years. It is industry leading. We have many customers, and the team is well set up and been using this technology for a while. We participate in various consortiums, and we are a Rapid I/O member. We are a PCI SIG member and NVM Express and HMC member. So what it does is we understand the specifications extremely well, so that it can implement these technologies very well. From a technical standpoint, we have architected in such a way that we have a very good IP, very good features, and it can be integrated very well. And we have very good focus on support, very clear focus, so that we can support the customers worldwide. We have support centers in the US, we have support centers in Asia. So wherever you are, whatever time zone you are, we can provide the support that you need. As I mentioned, the third-party partnership is a very important partnership for us. So in terms of 5 partners, verification IP partners, we already have it set up so that we can provide you the complete solution. And the last one is every IP that we create, it needs to be certified by either a PCI SIG or it has to be certified by the various forums. And we always take our design to these certification forums to make sure that it is certified and third-party certified. Okay, so our IP-centric approach, we start with our IP, but then we also provide customization services. We can provide the integration service and testing and deployment and any of the support related issues. So we can provide you anything IP centric, a complete service that our customer will need from us, an IP vendor. Okay, that's all I have. I hope that I gave a brief introduction to our IP capabilities and the portfolio that I have.
Questions? Yes, sir.
You want the T-shirt, didn't you?
Absolutely.
All right.
I thought I was going to win a Nexus if I ask a question.
Okay, sure.
So Ravi, how do you, with software becoming such a huge part of building a chip, and there's a lot of complicated drivers associated with your IP, how do you address the driver side of the equation?
I think it's a very, very good question. One of our advantage is the system level capability. And we believe that, I think you correctly said, the semiconductor is important, but the ecosystem around the semiconductor, like the device drivers, the development board, the RDKs, is becoming even more important. And our customers are looking for something that is totally, they want to use it, and all the components that are required to use in an environment, they need it. So we provide all of them for our customers. And many of the drivers, for example, the PCI and so on, it's already standards available. But if it's not available, we will provide it.
So you actually write the drivers?
We create the drivers. For example, NVM Express, we will create the complete environment, including the development board. And they can take it and they can use it from us.
No, they don't know that here, but you can sell software.
Yeah.
Sell software.
Yeah, it is an enablement for our IP, so we do provide that.
Any other questions? Okay.